So next we'll see about SIC XE machine architecture. This is the extra equipment of SIC machine. So it consists of memory. It consists of 1 megabyte. That is nothing but your 1024 KB of data in your memory. We can store 1024 KB of data in a memory. Then it will be having 3 additional registers. So it will be including the registers from your SIC machine. Also 5 registers is nothing but your your index registers, your linkage registers, PC, SW, and so on. And additional, there will be 3 registers, that is something but your base register. It is used for your addressing. S and T are general purpose registers, and used for arithmetic operations. And there is one additional registers of 48 bit to store your floating point value, and it is length of 48 bits. Remember, the other 3 registers will be having 24 bits, but the floating point will be having 48 bits. Okay, now data formats. You can store an integer in a 24-bit binary number, and we can store the negative values in a 2's complement. And 48-bit floating point data type. That means you can store your floating point value in a 48-bit binary number. Then exponent is between 0 to 2047. Now you can see the exponent value, that is your S, nothing but your sign value. Is it signed or unsigned? If it is 0, it is unsigned. If it is signed, it is a negative value. That means it is signed value. And 11-bit we can store the exponent value, and 36-bit we can store your fraction value. So if you want to convert this value into an absolute number, we can use this formula, that is f into 2 raised to e minus 1024 to calculate the absolute value of that instruction. Next is instruction formats. So there are 4 formats, as you can see in the below diagrams. Format 1 is of only 1 byte, format 2 is of 2 bytes, format 3 is of 3 bytes, and format 4 is of 4 bytes. So format 1, it consists of only opcode. That means instructions like rsub, return to subroutine. That means what is stored, only the address is stored in that. So we can use format 1 for it. Format 2 is nothing but opcode of 8 bytes, register 1 and register 2, 4 bytes each. So if you want to have some arithmetic operation, we can use this format 2 instruction format. Then next is format 3. As you can see here, your opcode we use only 6-bit, and other registers are nothing but your 6-bit NIXP BPE will be used as per the requirements, and S is nothing but the displacement value, which is of 12-bit. So E is nothing but value will be depending on zeros and 1, in which format we use. Is it format 3 or 4, depending on that value. P is nothing but your program counter, B is nothing but your base register, X is nothing but your index register, N and I value will be zeros and ones, as which to use format 3 or format 4. Okay, and in format 4, as you can see, the address is of 20 bits. Format 4 means it consists of 4 bytes. It means 32 bits of memory is used to store this format 4. Only the difference is address is 20 bits, all other is same as format 3. Opcode is also 6-bit, and all of the other values are 1 bit here. Okay, next, addressing modes. So it is simple addressing mode when n is equals to 0 and I is equals to 0. As you can see in the previous values, your N, I, X, P, B. So depending on these values, we will be seeing which addressing modes we will be using here. So if n is equals to 0 or I is equals to 0 or n equals to 1 or I equals to 1, it means it is a simple one. That means it is a SIC machine. We can use SIC format here. If your n equals to 0, I equals to 1, your target is target value, target address is nothing but the value stored in that displacement value. Indirect means when n equals to 1 or I equals to 0, your target address is nothing but your operand value. Otherwise, your base relative value, that means your when this is base relative addressing mode when b is equals to 1 and p is equals to 0. How your target address will be calculated is equals to the value of the base register b plus the displacement value. So displacement value will be so next we'll see about PC relative addressing modes. When b is equals to 0 and p is equals to 1, it is called as PC relative addressing mode. So target address can be calculated by PC, the program counter value plus the displacement value stored in the displacement field. So it can be your displacement value can be from minus 2048 till 2047. Next, some other addressing mode, direct addressing mode, when b is equals to 0 and p is equals to 0, your it is called as direct addressing mode. It is equals to your target address is equals to your displacement value. And index addressing mode when x is equals to 1, it is nothing but your target address, new target address is nothing but old target address plus the value of x. Then index plus base relative, when it is index plus base relative when x is equals to 1, b is equals to 1 and p equals to 0. Then we can calculate the target address by value of b, the base register plus the displacement field plus the index value. Next, we call as index plus PC relative when x is equals to 1, b is equals to 0 and p is equals to 1. So target address is calculated by PC plus displacement plus the index value. Now when it is index plus direct, when x is equals to 1, b is equals to 0, p is equals to 0. Then format 4 is when e equals to 1. Now there is one example given here, how to calculate the target address. So they have given some value b, that is some value here 006000. So similarly it is given for a program counter PC and index register 004090. Okay, and the memory address starts from 0 till ff bytes here. And there is some memory locations by the side. They have given some memory locations how to calculate the value, how to find the target address. Okay, so this is the example given here. Your opcode is all 0. It means it is using LDA. It is used to store from the accumulator. What is that? Data transfer is happening from memory to accumulator. So opcode value is all 00. The example we should take as LDA here. Operand opcode value is LDA. So all the value is 0 here. Now you can see some